What is up, everybody? Mr. Ryan Muckenhern to my right and Mr. Ian Klemm across from us. Today we're talking about something, Ryan, that I think is in some ways a little bit new to both of us, which is a little bit shocking to me.
That it's new?
To you.
Well, you got to understand I'm a hack. So the way I do things...
Here comes the modesty.
Well, the way I do things versus the way that Ian does things is very different. And I often tell people, I said, Ian has more records than I do, and that I have zero and he has many. And there is a reason for that.
He is well credentialed.
Yeah, and this will probably be one of those reasons, maybe.
Maybe. We're talking today about hard carbon rings, prevention, and removal.
Yeah.
Something that, I mean, you know, I'm reluctant to even clean a rifle.
Yeah.
Something it's not been on my radar, Ian, as a thing that I need to pay attention to look out for. Maybe I don't with what I'm doing. So let's get down and dirty with the carbon here.
Yeah.
Ian, what is a hard carbon ring?
Okay, so we all know what barrel fouling is. You know, you got copper fouling, you got carbon fouling. Sometimes you'll even have plastic fouling or lead fouling, you know, all of the above. If we just, for a second, put everything aside and look at carbon fouling, there's a couple different, grades of carbon fouling, if you will. There's real soft, kind of fluffy, sort of like chimney soot. And that's what you see, you know, come off the patch right away when you throw a wet patch down a bore. Usually on the cooler sections of the barrel, you know, 4 inches forward of the chamber, you'll get a lot of loose, kind of sooty carbon. This hard carbon is a completely different animal, and that's what folks are starting to talk about in the last couple of years online.
I'm not crazy.
No. It's something that went under my radar probably maybe until 6 years ago.
Yeah.
Yeah.
Okay.
And I think that's maybe what you were getting to when you said new.
Yeah.
And again, I never did precision rifle sports. I did multi-gun. And then, of course, I've been a hunter and a hand-loading enthusiast for a long time. And I can, remember when hard carbon ring, like all those titles on forums.
Yeah.
Whether it was long range hunting or 6MMBR or sniper side.
Yeah.
Everybody started talking about it. And I wonder, was it like the accessibility of bore scopes other than the Hawkeye coming to the consumer market?
I think it was.
Okay.
I think it was.
Yeah.
And it's because of those affordable digital bore scopes or bore cameras that people are educating themselves and trading, tradecraft on how to prevent and remove and realizing that, okay, it is actually causing a problem. Some of these barrels that I think folks thought were shot out in the past, I wouldn't be surprised if they use some of these techniques we'll be talking about in removing hard carbon if they didn't all of a sudden get resurrected. Sure. So it's something that's important enough if you are an enthusiast in rifle shooting and you shoot enough that you should know about, especially if you have a bore camera, because that's how you're really going to sort of tell how your cleaning is doing. Am I preventing the hard carbon from building up? Or now that it has built up, the harder problem is getting rid of it. So if we can draw one more time.
Oh, please do.
A picture. All right. Now this is going to be oriented kind of vertically here. All right.
I'm glad you're doing this because my next question was, where does this hard carbon ring present itself?
Yeah, great question. Okay, so this is the chamber of our barrel. And as you guys know, the brass fits in that chamber with a certain amount of serviceable clearance, kind of in all dimensions. Some places a little bit more than others, but that's our brass case fitting in our chamber. So where the carbon ring starts to grow, where it resides, is this no man's land between where your brass case ends, the very mouth of it, and where your lead starts in your throat. So we talked on a previous podcast about certain regions within within this chamber, you've got a neck, you've got something called free bore.
I like how it's something called free bore. What is free bore? Who is free bore?
Yeah, you've got the lead.
I thought it was a song.
Close.
Free bore and the lead together are the throat. And then this is where the lands of your rifling will start here. So really what we're talking about is that soft, sort of fluffy chimney soot carbon fouling that gets turned into something that resembles more like obsidian rock.
Sure.
Instead. It becomes this, through pressure and heat, it becomes this really hard black deposit. And if you've ever shot like 338 specials in a 357 Magnum, and then you've ejected those cases after a range session and looked at your cylinder, what do you see down there?
A ring.
You see a ring, and it's built up hard carbon. You take a muzzle device off, and you look at the internal surface of it, close to the the hole going through the center. What do you see there?
A ring.
A ring, yeah. So in this case, it's an especially troublesome ring of built-up carbon because it's right in that region that experiences the most heat and the most pressure. So it gets really hard to remove as a result. So what happens is it'll build up to a point, and unbeknownst to the rifleman or riflewoman, they think they're cleaning their bore really, really well, as evidenced by clean patches coming out after a cleaning session. No harm, no foul, pun intended. But this carbon will build up to the point where, what do we have, adjacent in this section here? We've got our projectile, right? And so if you've ever loaded a round of ammunition, and for whatever reason you unload your rifle and you see scratches or scuff marks on the bearing surface portion of that projectile right in front of the neck, you've got a carbon ring. If you suspect you did a bad job on a hunt or a match, and you come home and you say, I've heard about this boogeyman called the carbon ring, it's probably what did it to me, and you do that test and you have no scratches or scuff marks on that bearing surface of the bullet,
Still blame it.
El Nino. It's the fault of that phenomenon. No, you don't have a carbon ring at all. But that's sort of like the real litmus test for these carbon rings. They're easy to see once you get that bore camera down there and look at it. It looks just like that ring that you'll see on the inside of a cylinder or on the leading baffle edge of your can on the inside, just like it. Sort of like this glassy, dull buildup of material. And the problem with carbon rings, and the reason why they persist and why they have for so long, probably retired some rifles before their time, is because I can't remove them. Maybe someone better than me can, but I can't remove them chemically. So the two different kinds of ways you can clean your bore are chemically and mechanically. So mechanically, if you talk about abrasives, abrasive pastes, JB bore compound, IOSO, things like that. That is a mechanical removal of material through abrasion. Even the simple act of using a bronze brush is a mechanical way of cleaning your bore. I haven't found a chemical that will touch this stuff.
Unbelievable.
Yeah, it really is something else. Now, there's a product that I use to aid, to facilitate the mechanical removal, and that's a good penetrating oil, usually found at automotive stores. The one I use is called Freol, but people use Croil. Usually it's something that will take that hard carbon once you've sort of abraded it, put it in a suspension, lift it off the surface. I think the Freol has something a little bit more special about it. I haven't dug into it too deeply. I found it through online forums. Someone recommended, tested it out for myself, and sure enough, it decreased the time I needed to go after that carbon ring with a brush. So it does something as it's being abraded to soften that outer surface and facilitate that abrasion. But yeah, in my experience, you can only really remove that through mechanical means. Now, why why can't you just let it be? Why do you even need to remove it? Well, as evidenced by those scratch marks on your bullet when you seat that round of ammunition, it's making contact with your bullet. So we talked a little bit previously about the different variables that can increase your internal pressure. And the strongest one is actual bullet retardation, whether that be through a crimp or adhesives or a jam situation into your lead, or in this case, impingement by this hard surface, this carbon. Now, I'm not smart enough yet to know, is it, your neck length that's actually impinging on that built-up carbon, and it's sort of acting like the geometry of a crimp die. It's sort of forcing that mouth neck into your projectile. I have a feeling it's actually direct interaction between your copper jacket or copper monolithic projectile and the carbon itself that's causing increased stiction, therefore increased peak pressure during internal ballistics, and that's where you start getting the pressure signs in your gun. This load that you've trusted, taken a field for years, now is starting to shoot like it's overpressure. And you get vertical dispersion and erratic dispersion and all the things that come with that.
Okay. That's what I was going to ask. I mean, obviously, you're talking about, if you're going to blame your match on this or something like that. I was assuming it was those type of things, but yeah, I was curious to see how it manifests itself as the end result, where you might be want to look at that as a potential culprit.
Yeah, especially when, before bore cameras, you do a very thorough chemical cleaning of your bore. And you can look inside the muzzle end. You can sort of hold it up to ambient light and look inside and see shiny reflected light on your lands and everything. You think you're doing a great job, and this is what you're missing. This is what you can't see. And there's also hard carbon deposits, in the first few inches of your bore on top of the lands that you need to remove, usually mechanically as well. But this is the real culprit, that ring that forms.
I have many questions.
Yep.
I think sometimes things are said on the internet, and then like you made a really good point early on. Like there's kind of a press check that you can do to kind of determine if this is occurring, right? So we chamber that round, we pull it out, you look. There's a physical indication of some imparting force on the bullet jacket. Other times it's speculative. People think like, well, it must be that because this is what I'm seeing. And I think of things like I've heard recently that have come up and like people have reached out and been like, is this true? Where it's like, if you shoot a pure copper bullet down your barrel and then you go to shoot a gilding metal jacketed bullet down, the whole operation is out the window. Like you have to chemically scrub that barrel until it's down to bare steel, and then you can go shoot conventional jacketed bullets. And so I think I want to understand, like you had mentioned, this is new to you maybe 6 years ago, and you've been competing at a global level that whole time. Beforehand, what were you looking at, or what were you seeing, or what were you doing differently before you looked at that carbon ring for the first time and said, holy smokes, there it is?
I wasn't looking at it.
Okay.
I literally didn't want to spend the money for an optical bore scope.
Yeah, I get it.
so to me, I had a bucket of barrels that I had retired and a bucket of raw blanks that I was about to machine up and just pass go, collect $200 and move on and start with a new barrel.
Okay. And it was premature, you believe?
I know it was because I've since gone back and resurrected some of those.
No kidding.
That was my very next question. Did you retain that bucket of barrels, and then did the light bulb go off? And you're like, I should probably relook at these.
Yeah, absolutely. And I vetted it, empirically myself, and then they were good enough for Dad to put on his rifle, but maybe not mine. There's still the placebo effect of having that nice new barrel, but no, absolutely, it was the advent of that affordable bore scope that let me sort of say, okay, I'm connecting the dots here. I know what's going on, and I can prove it.
Little plug here. We did a podcast with Ian on bore scopes a while back.
Yeah,
which was that was enlightening.
They're so accessible now. That's the thing.
Amazon.
Yeah. And I don't know, half a dozen different flavors, flexible, rigid. There's no excuse really. If you're into this stuff, it's one of the cheaper accessories you're going to get.
Yeah. My reservation to owning I'll just say the Hawkeye because forever that was the bore scope, is simply auditing and then losing my mind.
Yeah.
In that, looking at guns that actually shoot for me good. And then I look down there and I'm like, what happened in here? I can't ever trust it. And me like getting that skull component rattling around in there and blaming things that aren't even happening. But I think it's something I should do.
I like that, living in that ignorantly blissful state for as long as possible.
Yeah. That's a beautiful place.
It could be on fire outside, but I'm still having fun.
Everything's fine.
Yeah. so then, like, you and I have different, I'm going to say ideas or opinions, yours founded in fact, mine just speculative, on bore treatment, cleaning, right? You have a regiment that you've explained to me before, and it's one that you employ, I think, to this day still, and it's brought you a great deal of success. Do you find that because of the way you clean your rifles, the like the time frame or firing schedule that you have, you're helping keep this at a minimum? Did you increase the frequency that you're cleaning your guns once you started seeing the carbon ring? Did you change any of that? Or was it was just like, no, I need to abrade it out of there and then start again, and it's going to grow either way. There's no way to stop it. It's just going to happen.
Yeah, I realized that I was giving myself false confidence in how effective my prevention methodology was. I was being gentle. I was taking a nylon brush and I was wrapping it with a patch, and I was using abrasives, but in sort of a gentle, sparingly, way. And then, I finally came to the conclusion after seeing how, I wouldn't say ineffective, but less effective that was, that I really need to use high quality bronze brushes for the purpose they're meant to, and dissolve myself of this idea that I'm shortening my barrel life. Because when you get right down to it, I want high quality experiences when I'm hunting, when I'm competing. I would rather have 80% longevity in my barrel, but every round that goes through that barrel is the peak performance. And after I sort of came to that, mental conclusion, then it was, okay, I need to get a lot more aggressive. I need to buy good quality bronze brushes in bulk. I need to not try to clean, 4 times with the same brush. I need to grab a brand new brush that hasn't been folded over. Its bristles are actually going to get into, this region. We'll talk about methodology a little bit, but that was sort of like the philosophical change that I went through, is I'm not really preventing this from happening like I thought I was. I need more elbow grease. I need more deliberate mechanical action in that area. And all by virtue of being able to see what I wasn't doing.
I think that's something, as long as I've been in the industry, I've heard people poo-poo bronze brushes. They're like, you're going to damage your bore.
Yep, me too.
And it's like, well, let's take, for example, a 308 Winchester loaded to 60,000 PSI. And think about the forces at work down your barrel when you hit ignition, and the temperatures and, particulate of powder in like almost a plasmatic state smoking the inside of your barrel. Like a bronze brush is going to be a gentle children's toothbrush in comparison.
That's right.
Right?
That's right.
And so I've not had an aversion to cleaning barrels for fear of damaging it. It's just fear of changing the condition where the gun is operating. And so then I come back to this cast iron skillet that I've removed what I believe to be some sort of
beneficial seasoning.
Correct. Yeah.
Yeah.
And then I've got to fire my rifle an unknown number of times before all of a sudden it starts to behave again. And maybe I need to revisit that, and I need to, work in a procedure that you're doing into my regiment, to keep me at peak performance and keep my shot-to-shot consistency or shot-to-shot performance as high as it can be. But it's never been about a bronze brush damaging a bore. That's a silly, and it always has been in my head. It's like a bullet ripping down that thing at 2,700 feet per second with a bunch of fire behind it is way harder on it.
But in our defense, I guess everyone else listening, their defense, a hobby and interest where we appeal to authority a lot. So if you have a barrel manufacturer telling you, you don't want to use this or stay away from, this product or whatever, that holds a lot of credence.
Sure, absolutely.
Just slightly less than your own personal validity after testing. So that's where I finally got to. It's like, okay, well, let me see, I'm willing to sacrifice a chambered barrel. Did it die in, 1,700 rounds versus 2,500 rounds? Turns out it didn't really shorten the life after switching to those bronze brushes. Of course, you can be, negligent with any method if you try to, but, if you're conscientious about it and you do it the right way and, employ good practices like bore guides and whatnot, then
I'm assuming you also run a coated or carbon rod.
Yep.
With a either a brass, probably a brass tip on it that's being threaded in there.
Yep. And being careful with, muzzle exit and reentry and that sort of thing when you start short stroking versus when you don't. That's all, a different topic, obviously. But moral of the story for problematic carbon. And I say it that way because you can let this build up and you'll never have a detrimental effect until a point where you do. So,
Well, and that's what I was going to say. Ryan did bring up an interesting quandary of this rifle is performing how I want it to perform.
Exactly. And that's where I was too.
Why or when do I mess with success?
Exactly, yeah.
And is that when the wheels fall off? But then what you're talking about, Ian, it's kind of like that ounce of prevention sort of thing.
Mm-hmm.
So do you wait till the wheels fall off, or is it more of a maintenance issue along the way?
Yeah.
Like, what's the better...
Well, if you wait till the wheels fall off, the problem with that, and it always has been, is you can't pick when they fall off.
Sure. Sure.
So if it's something that's high stakes, a lot of investment in time and resources, you don't want them to fall then. So that's where prevention is the big deal here. Let's say that we're all learning about this for the first time. We go home with our brand new bore scope and we see carbon rings that sort of in this area of our chamber that corroborate what our suspicions were. We need to get it out. It's going to be mechanical, like I said. When I first started to try and remove carbon deposits in that area, I would make myself tools. I would make myself kind of homemade scraping tools.
Yeah.
The first one I made, and let's talk the 308 example. I'd take a 30-30 Winchester case, deprime it, drill and tap that primer pocket to fit my Dewey rod, and then I would, spin it in a cordless drill, hold a file next to the rim until that rim was 473 or something-ish under, so it would pilot on the back of that chamber. And then I'd take a Dremel and cut some castle nut-looking notches in the front rim. So a fired 30-30 case, it's going to fit this neck diameter. 30-30 has a longer neck than the 308, so it's going to reach to the very end of that chamber region. And I could feel and see flecks of hard carbon come out with that tool. Looked like, coarse ground pepper almost at some point. The problem is that brass is relatively soft, and before long, those teeth at the end of that tool would sort of round on the outside corner, and they'd sort of fold in, and it wasn't very robust.
Yeah, high yield, but high effort to get there.
Yeah, very specialized too. Who wants to do that for every chamber they have in the gun cabinet?
Is that, I guess from a longevity of the tool perspective, not desired, but also for a potential, galling type effect?
Oh,
a good thing that it has some relief.
Yeah. So the softest barrel steel we're dealing with is 416 stainless, very cuttable. That's what kind of helps form the features you want inside of a barrel. But that brass neck wasn't doing anything, especially to a consequential part of your geometry up here. This is basically just the region where your neck resides in the chamber. So good question, but in my eyes, if you've got a well-fitting tool that will stop at this point and not go any further, no harm, no foul in terms of, scraping that carbon out with a tool.
Okay, gotcha. I just didn't know,
are you going to damage that barrel steel?
Well, are you going to damage it if you do it with something that's harder than the brass, I guess, is what I was saying.
Yeah. Well, if it's harder than that 416 stainless, you could scratch, and you will scratch that neck region of your chamber. So you don't necessarily want to do that. The carbon itself is a lot harder than that stainless. So the other worry is that, if you dislodge a big piece of that carbon and then it wedges itself like a chip would, to a reamer, when you're cleaning that area out, then it could scratch the ID of your neck and your chamber.
Wow.
So all those reasons to say that I kind of went away from the scraping tools. I had one friend who actually went to a reamer manufacturer and said, make me this chambering reamer. Don't cut any flutes except for the leading edge of the neck portion.
Yep. And that's what I was wondering next is like, well, how isn't there a product? And I'm thinking of like the AR-15 carbon scraping tools.
Oh, sure.
That you can just put in the back of your action and just go like this a couple times and cut it out.
Yeah.
But again, high effort, high yield. You know, a custom reamer is going to run you.
He paid $250 for it. Yeah. And the thing is, the carbon is so hard that you need to opt for the carbide reamer instead of the high-speed tool reamer.
And now there's high risk there, too, because we go a little deep and now we got problems.
Well, that's the nice thing. It's stopped on the shoulder.
Okay.
So that was all solid carbide that you used as a positive stop. So he really liked that tool, and I think he still uses it to this day. I wanted something that was a little bit more universal for just any chamber you have. So what I settled on, and this isn't the only way to do it. Sometimes I hate talking about barrel cleaning because you have to caveat everything to death. But your mileage may vary, and there's probably a better way to do it. This happens to work for me. Now we're done with that. I use an oversized bronze brush. Like let's say for 308, I would use 338 bronze brush. It fits this neck really, really well. And I grab a new one out of the bag. After this process, maybe it can be relegated to something, where it doesn't necessarily have to be full width, but I'll grab a new one so those bristles are, nice and sharp, blunt end. They're not folded over, and it'll get way down into this corner. And for myself, I haven't graduated to the cordless drill yet that I see some people do online. For me, it's just a non-rotating static pistol rod, and it takes 20, 25 revolutions. And then I sort of help it along with that free-all penetrating. I don't call it a solvent. It's more of like a rust preventative product.
Is it a soak or just a spray?
That's my question.
It's a spray on the actual brush. So I want the brush relatively saturated while I'm doing this. Now maybe I'll get out the cordless drill in the future. I see people do it. I think it raises the level of conscientiousness you need as the operator to make sure you don't go past this transition right here.
I'm telling you right now, if we ever get to the point in the conversation, we're like, I put a cordless drill in there, it will validate some of the things that I have done and thought, God, I hope this works. And I will feel so much better about myself. One of them was Mark's muzzleloader, not my muzzleloader, that had succumbed to the detriment of Pyrodex and 777 over time. And a 28 gauge bronze brush on a cleaning rod spun at about as high a rate of speed as you can get it going on a cordless drill will bring it back to a serviceable spot. Yeah, right quick.
I will say it shot like a house of fire.
Man, but I was nervous. I couldn't break it loose no matter how hard I pushed and pulled. And
did you tell Mark to sort of look away?
I didn't let him know until we went to the range, and he's like, man, that thing's shooting really good. I'm like, good, because it took two 28 gauge bronze brushes on a cordless drill hooked to a rod and a lot of oil. And
a couple toe straps. And
we got it done.
Here's the deal, though. You weren't going to ruin it.
Correct. Yes. That was also another thing, right?
Well, I think that's what gets us to some of these, breakthroughs in technique is we're kind of at our wit's end. We're like, I keep looking through the bore scope and it's still there. And you get to the point where, grab the bigger hammer. And before you know it, it's, gas powered implement. So,
but what's refreshing though, is like, you you're not to this point, and like at your level of experience and competency and credential, it's not like we're getting custom tooling made.
No.
These are 338 diameter bronze brushes that you can buy, like you said, in bulk.
Oh yeah.
And they're very affordable.
Yep.
And it's working.
And it's a oil that you can get at O'Reilly or Walmart. We're not talking boutique stuff. But let's talk about prevention, because getting rid of it does take some elbow grease, and you're going to have to go in there and you might have to do that process 2 or 3 times if it's a really thick, bad carbon ring. Once you've got it out of there, you can do some things to help yourself. One of them is don't give it so much real estate to lay down roots. I think a lot of people will look at a SAMI spec for casing overall length. In the case of a 308, I think it's like 2 and 15 thousandths. They'll look at that and they'll say, well, if I trim to 2, then I don't have to trim again for quite a while. What you're doing is you're giving that gap, you're making it as big as possible, and with more area, it's just a more opportunity for that carbon to actually start adhering. Once it starts adhering and gets sort of compressed with that pressure and heat, then it begets more growth. So if you can keep it from sticking in the first place through keeping that gap to be minimum. Now, you might buy a brand new box of brass and you take some calipers to it and you find that your shortest piece is 2 8/1000ths. You set up your trimmer to cut all of them 2 8/1000ths. That's awesome. That's what I do. Consistency is the name of the game, but don't cut any shorter than that. Sure. Don't give it more room than you need. If that lot of brass for that barrel is now on its 3rd firing, you measure all 100 pieces again, and your shortest piece is 2 10, 2 11. Go ahead and back your trim die off a little bit. Don't go over that, max of 2 and 15 thousandths, but give it as little room as possible to start building up. And then the other thing, the more obvious one, is the frequency of doing that quick operation with the bronze brush. It just never gets a chance to take hold. Sure. It doesn't mean you need an hour-long, full bore cleaning every time, but that's one area where, it'll keep those wheels from falling off.
Mm-hmm. Is there anything, like we've seen changes in chamber geometry in the past decade, like what was the way things were done is no longer. And now, we have these quote optimized chambers for given cartridges or bullet styles. Is there a way that can be engineered out of the equation or mitigated? Or is it just because you have to have some tolerance in there because brass length will be different, whatever in chamber layout? Can that be built out of a chamber?
I think it can, only to a certain point.
Okay.
The diametrical clearance between your size loaded neck and your chamber's corresponding feature, if you keep that to a serviceable minimum, this neck expands super quick to seal during a ballistic event, so you don't need a lot of clearance. I don't shoot anything that I have to turn necks for. It's got a normal amount of neck clearance, but I think if you went overboard on trimming necks and now all of a sudden you've got 4 or 5 thousandths clearance per side, well, you're giving once again more opportunity for that fouling to build up, because it won't only build up here. It'll build up in the lead a little bit. It'll actually build up in the neck to a certain extent. So when you're going in with that bronze brush, you're actually cleaning the whole neck to include that forward section there. Some guys, to get carbon out of the lead, they'll actually choose a brush, like a nylon brush, that will have its bristles sort of like biased to the rear, folded back. They'll wrap a patch around that. They'll put the croil or whatever your light oil is with a little bit of abrasive paste like IOSO, and they'll actually turn it, do that same operation, but they're turning in this portion. I get a little nervous about doing anything rotationally in the lead itself, because I don't really want score marks that are orthogonal to the direction the bullet's trying to go in there. We took our time to burnish those during the first 10 to 50 rounds during a new barrel's break-in. That, I don't want to put more score marks back in there. So I'm real careful about that. But in terms of other engineering things you could do, I think the reamer manufacturers grind this transition between the end of the neck and the free bore at like a nominal 45-degree angle. Was that arrived at, for any of what we're talking about, or just longevity of the tool? Probably the latter. Sure. To make that tool robust, so that a 90-degree transition here, you could easily chip that reamer flute, when you're manufacturing. So that could help you, but you might be trading one evil for a worse one.
What about, and I'm just grabbing at straws, surface coatings like nitride?
I think, I think if you make that surface less hospitable for a deposition of carbon, you'd be ahead of the game. Sure. You bring up a really interesting point. So nitride, even if there was no coating, but you took your time, initially to maybe use some Flitz metal polish and give it a better surface finish, so that things wouldn't stick quite as readily. You could be onto something there.
I wish we could localize nitride.
Only where you wanted it, yeah.
Because it is a superb treatment for many things, but it also has many detriments.
When we start, 3D printing barrels, with tri-metallic constituents, then we can do some fancy
just
stuff.
Just get that little nitride ring in there, and things will be golden.
Yep.
Have what do you see? And maybe it depends on the powder that you're shooting, your loading practice, your chamber tolerances, your individual barrel. What does this look like on your firing schedule when you start to see it show up? Is it instantaneous? Is it I'm 200 rounds in, I'm 600 rounds in, or it depends?
That's your favorite answer
is,
and I'm going to kind of give you a dose of your own medicine.
It depends.
Well, the fouling is so dependent on the specific powder and cartridge. It's amazing. It's really one of those things where get the bore scope and you'll see how fast is it growing, how fast is it depositing. I think one powder to the next might have, maybe not an order of magnitude, but half as much fouling as the other. So that'll change your schedule accordingly. Sure. On average for normal high power rifle cartridges, it's a practice that I would want to do about every 150 rounds.
Oh, wow. Okay.
So yeah, if you're shooting less than that, if it's a very, rifle season only kind of thing, then we're talking about something that you may never come in contact with.
Sure.
Yeah.
Sure. In the life that you own that rifle.
Yeah. I see it real often with some overbore cartridges,
Sure.
One of your favorites, a 7 Rem Mag, seems to exhibit this a lot.
Yeah. That's a dandy.
Yep.
Boy, just another check, huh, Ryan?
I'll keep his inbox full.
It's not their fault. I suppose that makes sense though, right? You got this huge powder volume. With that, if you're going to burn that fuel, you're going to get that smoke as a side effect of that, and it's going to show up there. And then you've got more flame, more pressure, more time.
Yeah.
It's going to deposit.
Carbon is a byproduct of this combustion that we're doing. You put sort of a fuel-rich source in your wood burner at home, you're going to have more creosote to clean out. Yeah.
If a person was starting off with a fresh barrel, Ian, and they did have, they were doing stuff where they had a high firing schedule, like they're shooting hundreds, thousands of rounds every year, right? Would you suggest, hey, get yourself that bore scope, maybe they already have it, and monitor this from the start just to get that A to Z perspective of what's happening in there?
Not only just for a raw education standpoint, but they'll see a clear cause and effect with their own practices that way. I have a feeling, the correct solution for a specific set of circumstances, this rifle, this cartridge, this is the way I drive it, will get narrowed in really quickly if they're looking at it regularly. And they'll say, oh, yeah, in this case, it needs to be every 75 rounds. And it's worth it to me to make sure that, I don't all of a sudden get pressure issues on my hunt of a lifetime, But yeah, in general, Prevention is easier than removal. Once you get that removed, you'll see, the effort that it took to get it out of there, and that'll sort of motivate you to keep it from coming back. Yeah, there's nothing. It's an easy phenomenon to see, actually. Some of these things is that fire cracking? Is that carbon on top of the lands? If you're not practiced at looking at those kind of things, you can kind of, take some learning there. But this one is so discrete and so finite that you're like, oh, yeah, it looks like a ridge of, igneous rock or something that's building up.
What's really cool about the borescope thing is, like with the Hawkeyes, if you've never seen them, they're a really cool tool. They're very beautiful. When you hold one, it feels like it costs as much as it.
Yeah.
But it's raw optical. There's nothing about it that translates it to a computer screen. I mean, you can hold your phone up to it and take a picture. With some of these new ones, they come with a little digital screen, or it Bluetooths to your phone, and you can screen capture it. And now, if you Google carbon ring in chamber and you hit images, you can see 100 examples of this, or fire cracking, 100 examples of this. And there are some really, really detailed images and explanations. Like some of the guys and gals that are like truly top tier in rifle craft that will diagnose and show, just like you would in a medical journal. Like, it's this rash means this rash means that. And you can see this all now. And so these new borescopes, they're not even necessarily sold as borescopes, but
endoscopy, 5mm camera.
And you can now, the digital age has brought us to the point where diagnosing this has never been easier, which is fun. I still don't want to buy one because I know what I'm going to do. The first thing I'm going to do is every single bore is going to get looked at, and I have too many of them now, and then I'm going to start getting the willies, but it's going to happen. God dang it.
Yeah.
Ignorance can be bliss.
It is.
It can bite you.
It is. I don't have yet. I don't have a lathe, so I'm not to the point where it's like, well, let's try a new barrel on a weekend schedule. But my garage is wired for one, so maybe it happens. I don't know. Well, this is cool.
Yeah, I appreciate it, and it's always, it's always just super fun chatting with you. Learn a ton. And, there you have it. The who, what, where, when, why, how of hard carbon rings, what they are, how to prevent them, and how to remove them if you need to.
Yep. Not that hard. It's hard, but not that difficult.
Yeah.
Yes. Awesome.
It doesn't require surgical tools.
There you go.
Yeah.
Mostly. All right. Thanks, everybody, for listening. Thank you, Ian. Thank you, Ryan. Happy hunting and shooting. Are you going to buy a borescope? Are you going to dive down that rabbit hole and start? I'm looking at you and the audience,
Probably.
Ryan. Tell us what you find. We'll catch you on the next one.
See ya.
Thanks.